Can you explain how free and total testosterone work with SHBG?
All right. So, so testosterone is made in males predominantly in the testes, and it's made from cholesterol. And as many might know, cholesterol is a fat. And fatty things, let's call them that, fatty molecules or fat-soluble molecules need to be transported in the blood, like cholesterol. That's what we spoke about. So just like if you put a bit of fats or oil in water, you don't see the oil dissolve.
Yeah.
You don't want that with sort of a fat-soluble products in our blood. So we sort of dissolve fat-soluble things by binding into a protein. Okay, that LDL and HDL, those are proteins that bind fats to solubilize them in blood, essentially, and transport them. For testosterone and other sex hormones, we have what's called SHBG, or sex hormone binding globulin. So it's a big name, but it's basically just a protein that binds sex hormones, testosterone and estrogen, etc., to transport them around the body because they are fats. Okay. However, so this is how we transport these hormones. However, when testosterone is bound to sex hormone binding globulin, or SHBG, it's what, let's say, inactive. We know use two technical terms, but it's not available for use by the body. And when we measure total testosterone, we're often measuring how much testosterone is bound to SHBG. You can't really tell the difference. So in clinical practice, you might have normal testosterone levels, but that testosterone might be bound, most of it, and it's not available for the body. So you could still have this sort of clinical scenario of low testosterone, even though testosterone levels are normal. So that's what we call total testosterone. You don't really differentiate how much of it is bound and unavailable to the body for use and how much of it is free. So this now brings the other context. You've got your total testosterone, and then you've got this concept of free testosterone. Okay, there's another one that's related to that called bioavailable testosterone, but it's the same concept. I won't differentiate those two. But essentially, when testosterone gets to its target, it needs to come out of the blood and go into the tissues, and it releases from the protein that's in the blood. And then it crosses cell membranes, it goes into cells, and it attaches to receptors, and it does its job. That's when it's free or bioavailable, that's not attached. And of course, you need the right amount of that of testosterone to be free in order for it to be doing its work. And we can also measure this in clinical practice. So you can measure total testosterone and free testosterone. I always do both. And free testosterone is often calculated by a ratio using the SHBG levels and your total testosterone levels, which is fairly accurate. There are other ways. You can do saliva testing for free testosterone, which is probably better. It's not as readily available, and it's a lot more expensive, unfortunately. But it is a lot more useful, and specifically that's what we call bioavailable hormone. It's hormone that's not only free, but it's in the tissues doing its job. You can have a scenario where testosterone looks normal if you just do total testosterone, but you do free testosterone, you might find that that's actually low. Maybe because sex hormone binding globulin is high. Sometimes that's high for various reasons as well. And if that's too high, you binding too much of your testosterone and not enough is available for use.